Hello, everybody. My name is Paul Beckwith. We often talk about the AMOC, the Atlantic Meridional Overturning Circulation, and how it's changing. And then more recently, I've had some videos talking about the changes in Antarctica, what appear to be regime changes in the sea ice, but also the effects on the SMOC, Southern Meridional Overturning Circulation. I like that acronym better than the AOC, which some people are using for Antarctic Overturning Circulation. Anyway, the ocean currents are, of course, vital for transporting heat around the planet and nutrients and oxygen and for supporting the oceans. I mean, an ocean that's not dynamic, that's not moving, is basically a dead ocean. I was fortunate enough to attend a seminar yesterday with Russ George, who did the ocean iron fertilization. He doesn't like the fertilization term. He says, when we fertilize a field, we put nitrogen and phosphates on in large quantities. But when we add iron, it's a micronutrient. I mean, it's a very small quantities, 1,000 times lower quantities than nitrogen and phosphor. And we put it in regions that are iron deficient, and we can stimulate phytoplankton bloom. So a very interesting seminar, and I'll post the link on social media when I get a hold of it, when the video comes out. But I want to talk about the Kuroshio Current, which is the current running from you have the North Equatorial Current in the Pacific Ocean running from east to west, and then when it reaches the land masses of Asia, Indonesia, that region, then it heads northward. It's basically the Kuroshio Current, and then it comes up and crosses into the North Pacific Current, and there's also a current called the Kuroshio Current, which comes down and meets the Kuroshio to form the North Pacific Current. And so I was very interested when a paper came out recently that Jan Umstonst discussed about changes to the Kuroshio Current that we've observed in the last few decades. So that's what this video is about. Newton's avoiding me right now because I was making so much noise yesterday, mostly last night, with this device here. The end is like this. If you're not handy and know nothing about plumbing, then you don't know what it is. It's a snake, basically. It's a plumbing snake. I've been having problems. I'm in an old house, and I guess there weren't, over years, stuff builds up in the pipes and so on. So usually I can go down with a snake and clear it. This one actually consumed a couple snakes, and I used heavy-duty plunges and some interesting techniques. I figured out a way to send surges of water down the pipe and then up the pipe and then oscillate it back and forth with the plunging I MacGyvered the system because the air vent coming in, water won't drain in a bathtub unless there's an air going into the system, which is done in a vent just underneath the taps. So I took off the cover and I used this, which is a stress relief ball. So I've been using this a while because plumbing repairs can be very expensive, but I needed it to physically block the air vent when I was plunging. And then by changing the sequence of blocking, plunging, pulling back up, changing those sequences, I could get an oscillation of water going up and down the pipe to clear it out. And I created, I basically filled the bathtub with dirty, filthy, scaly hair water, the grossest water you could see. So I've always got, if the video thing doesn't pan out, if donations, aren't there enough to support my work, I can always go and become a plumber. It's AI proof. You're not going to lose your job. I mean, who wants to go and fix toilets and, it can be pretty nasty, but you see the plumber, having a really nice house, driving a really nice car, and, that is going to continue long into the future, especially as our homes and infrastructure ages. So if you're looking for, the trades, some of the trades are very, very good for young people to go into, or, old climate scientists to do sort of moonlight on the side to cover some costs to produce all these videos. Anyway, that's enough rambling today. I may have set a record, first 5 minutes, just talking about stuff like that. I wanted to show you, we often talk about the Gulf Stream, how it's slowing down. There's less warm water carried up into the Arctic, and with less water going to Europe, Europe could go into a deep freeze. Meanwhile, this water would pile up over here, greatly raising sea level here along the eastern coast of North America. And then, of course, we have the AMOC version, the Antarctic, the currents actually, it's not really clearly shown here, but there's different currents around Antarctica. There's some subpolar current. Anyway, the AMOC system, where the water, warm water comes up, gets colder as it goes poleward, it's salty, and it sinks down, as the ice is formed, it sinks down to the seafloor. Well, the same thing's happening with the SMOC, which I mentioned slowing down, but we don't talk about the Kuroshio Current, this current here, very often. So I'll just go through. This is the Wikipedia page, which I'll show the link to. So it's showing deep currents, different ocean patterns. This is phytoplankton, and this is a generic sort of global circulation showing Hadley cells and Ferrel cells and polar cells and trade winds, etc. But this is a really cool map. So, it shows, sea ice. It shows very detailed currents. So right now we're talking about, so here's the North Equatorial Current, and then the Kuroshio Current coming up here. It gives a very good depiction of the Gulf Stream coming up across, how it splits into the two. I really like this map, and then how it circulates back, and so on. I love this map because it's got lots of tremendous detail on these ocean currents. Okay, so, and this is, you dip this thing down deep into the ocean to collect water samples at various depths, and get information on that. Okay, so it's a great site. You can get it by going to Wikipedia Ocean Currents and just clicking on this image here, and it gives all the other images. So this is an excellent site. Okay, so let's go to the paper here. So this is the IOP Science Environmental Research Letters, fairly recent paper this year, or late, actually last year, January 25th, 2024. Observations reveal onshore acceleration and offshore deceleration of the Kuroshio Current in the East China Sea over the past 3 decades, 30 years. Okay, so I downloaded the PDF. It's open source, and let's have a look at this paper, what it says. But before I do that, I just want to show you a couple more things. You can get lots of good information on the Kuroshio Current from the Wikipedia page and what it does, its importance for fisheries, when it was discovered, physical properties, sea surface temperatures. There's images of, so these are the ocean currents surrounding the Japanese archipelago. One is the Kuroshio here, and then you have Kuroshio extension, and you have a counter current to the Kuroshio here. Current this way. Of course, you're going to get these eddies forming. Russ George spoke about eddies, the importance of ocean eddies, and his talk. And then you get the, this is the Tsushima current, the Tsushima current coming up here. And then you get the Sugera current going through the islands here, the Soya current, And this is, another current, the Lehman current. So the Kuroshio is the main one, right? Brings up heat from equatorial regions to higher latitudes. It's sort of the Pacific equivalent to the Gulf Stream, if you like. So they talk about the strength, how it varies, relatively steady, 25 sverdrup, right? A sverdrup is 1 million cubic meters per second. The Amazon River is about 0.2 sverdrup. If you add the flow rates of all the rivers of the planet together, you get about 1 sverdrup. Okay, so the ocean currents are massive, and they talk about sediment transported. This is a good site, a good NASA visualization of the ocean currents. It's beautiful display if you watch it and listen to the music associated with it. I think that video's still up. Tropic cyclone tracks, and so on. All these things are connected to the Kuroshio Current. Okay, so it's a really good site. And then I have I looked at the Wikipedia sites on these other subcurrents, and some of them are there, some of them are not. Like the Lehman Current, which is 8 right here. There's no Wikipedia page for it, so I went on, and it's a Japanese site, and I just did the translation to get the discussion on this particular current. All the links are in the description. Of course, Fukushima. People have heard of Fukushima up here on this coast. You know how the currents affect where the radiation would be carried from leakage. So there's information on that, and then the bathymetry. The bathymetry of the ocean. There's some good images here, and you can look at the sort of bathymetry of the area around Japan. This is some more data here showing the water depth at different places around Japan. So you got the Kuroshio coming up this way, and this is Google Earth. Another good image here. So we've got China here and Taiwan here, the Philippines down here. So the Kuroshio comes up, and the Kuroshio comes up along this barrier, more or less, right? There's an ocean barrier where you go down into the abyss here off Japan. So this is a great site, Google Earth. You can play around and get different information on like down here minus 5,000 meters. Okay, so that's the water depth, right? It's even there. This is only 100 meter depth here, 200 meters, and then it goes down into the abyss. Okay, so you can get a lot of good, and here it's a lot steeper, right? Over here, water's minus 500 meters deep. Over here, 5,000 meters deep. So you can see the variance and graduations and stuff. So it's really useful when you're looking at the ocean currents to know something about the bathymetry, because that's part of the reason that the ocean currents are where they are. Okay, so the net result is basically the data is showing the Kuroshio Current in the East China Sea, one of the most prominent components of the ocean circulation system in the North Pacific. So we're getting over the 3 decades of data onshore. We're getting closer to the shore over the continental shelf. We're getting intensification or strengthening of the Kuroshio Current, and that's driving nutrient-rich upwelling in the continental shelf regions. So the anomalous global warming, is leading to coastal marine heat waves, which decreases the viability of the fisheries and so on. It reduces the ability of the oceans to absorb anthropogenic carbon dioxide, to be a carbon sink. So based on the data, in situ observations from ships, ocean buoys, etc., altimeter data, right, warmer water expands, so sea level in that region is an indication too of the temperature of the water. They find an onshore acceleration and an offshore deceleration of the Kuroshio Current over the past 3 decades. The intensification is characterized, so there's a spatial difference, onshore, offshore. The onshore acceleration is 0.39 centimeters per second per decade. So that's the speed of the acceleration of the current, 0.39 centimeters per second per decade over 3 decades. And offshore, there's a deceleration of the current, it's minus 0.63 centimeters per second, the velocity of the water per decade. And they're attributing this change due to the changing air circulation patterns and other things. It's attributed to changes in the wind stress curl. So that's the wind stress and cause, effect on the curl is a cross product, if you like. It's the forces on the water, moving the water. And also they're attributing it to oceanic stratification over the subtropical North Pacific, right? Warmer water is lighter, tends to stay at the surface and reduce the vertical mixing. Very, very serious situation. This is seen throughout the world's oceans, and there's some interesting papers recently specifically on stratification changes, which I'll probably do a separate video on. So the weakened wind stress curl decreases the vertical extent of the Kuroshio current. It reduces its transport, the flow rates. It contributes to an offshore deceleration of the current, whereas the enhanced stratification drives the uplift of the Kuroshio current, and that uplift of the water from down deeper to lower over the continental shelf contributes to the onshore acceleration of the current. So it's interesting that it's variable depending on the actual location in the Kuroshio current as to whether it's getting stronger or getting weaker, unlike what's happening to the AMOC, the weakening, the Gulf Stream weakening, and then overriding the continental shelf. Okay, so it's very important to have to establish and maintain a monitoring network for the zonal variations of the Kuroshio current to find out the impact. So, it's basically the Kuroshio current. It's one of the most prominent components of the circulation system in the North Pacific Ocean. It's an efficient conveyor of mass and energy between the tropical and mid-latitude regions. So it carries a lot of heat from the tropical regions to mid-latitudes. And they talk about how it's originating from the bifurcation or splitting of the North Equatorial Current. It flows northward along the eastern coast of the Philippine Islands and Taiwan Island. To the northeast of Taiwan, it flows over this ridge, enters the East China Sea. Okay, and then it meanders along the continental slopes of the East China Sea with a stable volume transport of about 24 sverdrup. 1 sverdrup is 10 to the 6 cubic meters per second, equal to the cumulative flow of all the rivers of the world. And then it exits the East China Sea through this Tokara Strait, and so how it changes from climate change is very, very important. Has impacts on the continental shelves, on fishing, on coastal seas, on marine heat waves, on stratification, on intense nutrient-rich upwelling on continental shelves. Right as the water overrides the continental shelf, it's forced upwards. That fertilizes the coastal areas, important fishing grounds with nutrients. The onshore movement, anomalous onshore movement of the Kuroshio current could result in significant warming of the Pacific Asian marginal seas. Okay, so it has a lot of spin-on effects, and they talk about actually methane hydrates. They say this warming could destabilize or even lead to the release of a large amount of methane hydrate stored beneath the seafloor of shelf regions in the East China Sea. That would, of course, be a geological disaster, greatly warming the planet. I'll have to do another video on methane soon. I haven't covered methane for a while. So, based on temperature, reanalysis, and model products, the subtropical gyre in the North Pacific is undergoing poleward intensification, enhanced warming in the Kuroshio regions, but there's limited data and stuff. So this paper, looks at the latest stuff. So let's just have a look at some of the results. Okay, so this is trends in the surface velocity, essentially in centimeters per second per decade in the Kuroshio Current region between 1993 and 2021. Okay, so what you see here, this is Japan up here, this is coming up here. You can see on Google, go to Google Earth and see those island chains, and you can see exactly where we are. Maybe I will do that. Where did I, this is it. Nope, this is it, Earth, Google Earth. Actually, I wanted Earth Null School here. Well, Google Earth is okay. So we're looking at, see these island chains here? These are the island chains, so the current's coming up here. And there's a couple islands here, and it's coming up here. Okay, so that's the region that we're basically showing up here, these islands. And what we're seeing is centimeters per second change in the Kuroshio Current velocity, essentially. The red is an increase, 0.4 centimeters per second per decade in the red areas. It's an increase. So the current is increasing here. And this is the main sort of mean line of the current here. Or this is a dividing line, actually, of the current. So on this side, on the coastal sides, it's increasing flow rate, volume flow rates. And on the ocean side, it's decreasing in strength. And it's decreasing actually more than it's increasing over here. So you can see the general trend. You get an increase here, decrease here, and actually an increase here, which they're not talking about really. Anyway, so this is how, so it is changing over time. And this is a bathymetry image showing as you go to, this is that line, dividing line again, as you go towards the coast, this is with depth, we're increasing, this is centimeters per second per decade in the red, and the highest is the biggest increase. So we're increasing the speed of the Kuroshio Current on the coastal side, and then on the ocean side, it's actually decreasing at an even larger rate in some areas, some central areas. Okay, so this is basically what this paper is studying, and then they go into some of the physics of the wind forcing and the ocean stratification effect. So they look at the wind speeds in different locations and how they're changing, wind stress curl. They look at the stratification, and like I said, I'll talk separately about stratification in a future video. So the conclusions are the observed onshore acceleration and offshore deceleration of the Kuroshio Current over the past 30 years. It's attributed to both the weakened wind curl stress. So it's weaker, the wind curl stress, and there's also more stratification over the subtropical North Pacific, right? Because of warming, warmer water tend to get more stratification. So this induces transport reduction, less current flow, uplifting of the Kuroshio Current over the continental shelves a bit, so it's increasing in strength there, and it's weakening. So basically what we're seeing here, they talk about the slope of the bottom topography and some other effects, but and this is important. It says, our discovery is an important finding with profound implications to nutrient upwelling, to fishing in the region, but I'm thinking more of the sort of global climate circulation system, both in the oceans and atmosphere. This is indicative of changes in that. So basically, if we go back to this image again, you can think of this as, if the current used to be flowing over here a bit more, and it's moving actually up the continental slope a bit and flowing here now. Of course, this region will show a big strengthening, and this region will show a big decrease. So they talk about the actual division based on the mean of where the current is, but I think it's more indicative of, I think they'd be better to draw a line of where the current used to be and where it is now, and you can look at the shift of the current, because that's causing these effects. These effects. And the Gulf Stream, as it slows, it's expected to override the continental shelves more. And I bet you, if you looked at the location of the Gulf Stream off the US coast, you could see it's actually shifting as well. So the Kuroshio Current is essentially doing the same thing as the Gulf Stream is doing. So I think this is a very important paper and a very important finding. Please go to my website, paulbeckwith.net, and donate PayPal to support my research and videos. I'm very active on social media. There's a little blurb in the video description on all of the different social media platforms I'm on. So please subscribe if you haven't to my YouTube channel for my videos, and repost and reshare. Find me on all these social media platforms and follow me, and I'll follow you back. Okay, well, thank you for listening, and bye for now.